Here's a GRE algebra question. Let's take a look. Each month, a certain manufacturing company's total expenses are equal to a fixed monthly expense plus a variable expense that is directly proportional to the number of units produced by the company during that month. If the company's total expense for a month in which it produces 20,000 units are $570,000, and the total expenses for a month in which it produces 25,000 units are $705,000, what is the company's fixed monthly expense? Okay, let me just acknowledge here, this is a long, wordy question, right? And because it's so long and wordy, it's going to take a long time to solve, no matter how easy or difficult it is conceptually. It's just going to take a long time. So strategically, if you run into this question on the GRE, my advice is to flag it and come back to it later, right? Just in the interest of time. But assuming that we do want to solve this question, let's get to it. So the situation that we have here is basically summarized by the following equation. This is sort of the standard cost equation for running a business. Your total cost is equal to your fixed cost plus a per unit variable cost times the number of units. So I'm going to say the number of units we produce, U, times V. U and V look a little similar, so I'll make that nice and round, and that's nice and sharp, right? So your total costs come from the fixed amount of costs that you incur, plus the per unit variable cost times the number of units that you make. And I'll put this in concrete terms. Let's say you're running, a rubber duck factory, right? And you have to pay some fixed expenses. You have to pay for the rent for the rubber duck factory. You have to pay for the electricity, right? Doesn't matter how many units you produce, you have to pay these expenses each month. But then you also have to pay a per unit cost. So maybe every rubber duck that you make, you have to buy a certain amount of rubber, or you have to pay your employee a certain amount of money, right? So every unit that we make, we incur more cost, and so as the number of units goes up, the cost goes up. Well, we basically have two situations here, right? We have the first one where we've incurred $570,000 of cost. That's my total cost, $570,000. And that's made up of some fixed cost, I don't know what that is, plus 20,000 times the variable cost, right? 20,000 is the number of units that I've made in this scenario. So this is the first equation. And then the second equation comes from this. The total cost is $705,000, and that's equal to the fixed cost plus 25,000 times the variable cost. Okay, and you might see where this is going now that I've written two equations. But if you don't, or let me just point out, right, the hardest part of this problem is the setup, right? Running through all this information and pulling out what we need. How did I know that I needed to make two equations? Well, there were two scenarios, right, and two prices. And that sort of hints at, drumroll please, a system of equations, which is what we have right here, right? We have a system of equations right here. And if you're not familiar with systems of equations, I would review those. But what we have is a system, two variables and two equations. And so let's solve this. One way you could solve a system would just be to isolate one of the variables and plug it into the other equation, right? Totally works. But the cool, sneaky way to do this would be to do the elimination method. And I'll show you how that works. I can just subtract one equation from another. Wait, you can? Yeah, you can. And here's why. Equations are basically like balance beams, right? A balance beam says, hey, whatever's on this side is equal to whatever's on that side. And if I have two balance beams here, I can totally just combine both sides of the balance beam, either by adding or subtracting both sides, and I've maintained the equality of the balance beam. So I can just subtract both sides just like that. So let's do it. $570,000 minus $705,000, use your calculator, comes out to negative $135,000. And that's equal to this side of the balance beam, subtract F minus F, gone, nothing, no more F. Right? Isn't that nice? Only one variable left. 20,000 V minus 25,000 V gives me negative 5,000 V right there, right? And now I can solve for the variable cost. Just divide both sides by negative 5,000. And when I do that, I find that the variable cost, that is the cost per unit, is 27. So it costs me $27 for every rubber duck that I'm making. I better be selling these rubber ducks at a pretty high premium, right? Okay, but I'm not done because we want to know the fixed value. We want the value of f. Well, how do we get that? We just plug this value into either one of these two equations and we'll get it, right? So let's do it. I'll take the first one. 570,000 is equal to f plus 20,000 times 27. That's my v, okay? And then I just solved this equation here. 570,000, boom, 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 equals f plus, do this on your calculator, 540,000, almost there, folks. Subtract 540,000 for both sides. What do you find? F is equal to 30,000. There it is. Answer option B is correct here. For more GRE tips and tricks or to sign up for my online course, follow the link on my profile.